Hi guys, section 1.3, here's a sample set number one. This is the end behavior type limit. So we want to take the limit as x approaches positive infinity. So on a graph, we are going this direction and we want to know what the y value is approaching as x approaches positive infinity. Again, these behave just like the end behaviors that Casulo taught to you 2 years ago, where we find the one with the biggest exponent. That is the degree of the polynomial. The rest of the polynomial is inconsequential. We throw that out. And we throw positive infinity in for x. X to the third power is positive infinity to the third power. That's positive infinity times that negative 3. The result, negative infinity. How Casulo would do this problem algebraically is, since it's an odd degree with a negative coefficient out in front, odd degrees with negative coefficients start high and end low. Where it ends is the same answer as its behavior as x approaches positive infinity. So we're doing the same type of problem that you did in algebra, but we're just adding a little calculus twist with the nomenclature. Number two, it behaves like the highest power of x, so this polynomial only behaves like this guy, and this is inconsequential. We throw that negative in here for x, and when we raise that negative infinity to an even power, it becomes positive. So negative infinity to the even power, that's positive infinity, times the negative 5 out in front, that changes it to negative infinity. Okay? So as x approaches negative infinity, so does y. We could look at what Casulo would do on a problem like this. This is an even degree with a negative exponent. It's going to behave just like a parabola would. Concave down because of the negative exponent. It starts low and ends low. This is a fancy way of asking, when it starts at negative infinity, what's the y value approaching? Negative infinity. So starts low. I hope that makes sense to you guys. Throw a negative infinity in this one. Again, these other terms are inconsequential. It'll only behave like the highest power of x. Throw negative infinity in here and see what happens. A negative infinity to an odd power, it becomes a negative times a negative, which is a positive, times another negative, which is now a negative. And a negative times a negative is a positive infinity. If that's too much for you to keep track of, no worries. It's an odd degree with a negative coefficient. Odd degrees with negative coefficients behave like this. This is the question. It starts high. So it starts high, and high is positive infinity. Take a look at this last one. When you throw a negative infinity into this entire equation, that negative infinity squared times 4 is going to be positive infinity. When you put that in here, positive and positive, positive. If we change this to a positive 100x, now insert negative infinity and see what happens. When we throw negative infinity in here, that turns positive, times the 4. That's positive, and it's huge. We put a negative in here. Oh my gosh, this one's going to be negative. Which one's bigger? This guy at positive infinity, or this guy when I shove in negative infinity? And the answer to that question is exponentially. Infinity squared is going to be much larger than 100 times infinity. That's why it's only the term that could creates the degree that makes a difference. Okay, the highest power of x is the only one that gets to participate. And we throw that negative infinity in there, square it, it becomes positive infinity, times it by 4 is positive infinity. So the y value is going to the positive infinity as x goes to negative infinity. It starts high because of the degree and the coefficient out in front. I hope these videos are helpful. The next one will have some samples of rational equations and how they work.